So I want to talk a bit about scaling your auditing events, and we'll see why and how and where this is going. So before we start with the actual tech stuff, let's see where we are security-wise. Oftentimes, we say everything is fine, and this could be, I don't know, our builds, our Kubernetes cluster, but especially oftentimes this is what we have in terms of security. And we always say that you have three levels of security incidents that you might run into. One is more like for your information, which is like, okay, something is not so good, but you should know about it. Otherwise, okay. Then it's what the fuck, like, I don't even know what is going on. And then there is the oh my God level when everything is broken and on fire. So these are probably the three levels on which we operate when we talk about security. And just to map that to how you can learn about it is the worst case is probably from the press or from your users who say like, hey, by the way, we found our data somewhere, or somebody has published this embarrassing report about you. What is also not so great is if somebody is trying to ransom you for your own data, for example, or threatens to, I don't know, take away data, sell your data, whatever. So you don't want to be in that position either. What is less bad, but still bad, is if you see on your cloud provider's bill that somebody has started mining Bitcoins in your account and it's just getting very expensive for you. Ideally, you know or learn yourself first that something happened. And in the best case, you can also say like, okay, this is what happened, and actually it was not that bad. And what I want to cover in this talk mostly is that it was not that bad, or what actually happened, how to do that auditing and see what actually happened to your account, and both find out what bad stuff happened and be proof that it wasn't hopefully that bad in the end. Obviously, there is no silver bullet, and I'm just showing you one possible tool here, or some possible tools, but this will probably be an in-depth approach. So you don't want to run just one tool or rely on one technology, or like layer in that technology, but to have like the right combination. I will show you different pieces and how they might fit together. So the first thing I want to dive into is Auditd. And if you have never heard or seen Auditd, it's part of the Linux auditing framework. It lives on github.com Linux Audit. And it basically says you have a user space component into that auditing system, and that is responsible for writing out these audit records. And then you can just view them and see what they're doing. This is directly taken from the man page of Auditd. So Auditd is basically the thing in the background that protocols what has been happening security-wise. And it has a lot of features. So for example, it can check like what files are being accessed, what is the network access, like which sockets have been opened or which connections have been established, what system calls you're doing. So you could filter out specific system calls. You could figure out like what commands have been run by a user or what security relevant events have happened. And how this works in general, this graphics here shows you, so you have your application, and then that application does a call in the kernel, and that you have this call filtering, and basically any of these three things, so based on the user, based on the task, or based on the exit code. You then have an exclude filter, and you can say what should not pass through here. Anything that passes through here will actually be logged by the auditing daemon. So you can say like, these are the things that I want to exclude, or these are the things that I want to include. And then you can filter those out, and the auditing daemon will collect those things based on users' tasks or exit codes that you're running here. And I can give you a quick idea of what that looks like. So I have a server running here on AWS. It's an Ubuntu server. And I have been running Auditd for a short amount of time just to collect a little data. And you could, for example, see the report with sudo aureport. And this is just showing you an overview. So you see that this is when I set this up, and it was just running for like 20 minutes or so, or 15 minutes. I ran Auditd, And you can see, okay, there were 3 changes in configurations and that many changes to accounts, groups, or roles, and 17 logins in that time frame. 0 failed logins, etc. So these are all the things that you can see on a higher reporting level. How do you get to the actual events? Well, so rather than report, you can do ausearch, and with -- raw, I get to the actual events or the log lines that Auditd is actually collecting. And if you look at those, they look a bit arcane and maybe a bit like a mess. So for example, here, this is one entry. So you can always see every line starts with type and then whatever thing happened here. So for example, this message is actually that I stopped the Auditd process. So the audit process was terminated and that was successful. By the way, with ausearch, you could add -- success, yes or no, to filter just on successful or unsuccessful calls as well. And just one of the ways to slice and dice your data here. You have a timestamp and then a unique ID. If one specific call causes multiple auditing events, then those could even be the same, so they don't have to be unique. And you could see, or you can see that every single line here or every single type of event can be different. So you can see the user start here has different attributes than the other one. So for example, this one has terminal and address and host name that the other command doesn't have. So different lines have different formats and you need to understand basically all of them to make much sense out of this. Just to point you to where you could get more information on that one. The Reddit documentation for this is actually pretty good and it shows you a couple of examples and then walks you through all the different fields that are in there. So you can see this is the timestamp and the ID, and this is this slightly arcane format for this one here, for example, or the system call, and then you could look up the code for the system call to actually know what this system call was and the success and the exit code, etc. So all of that you could see. And you could also, with ausearch, you could filter on that. So for example, you could just say like, show me all the exit codes -13, if that makes sense for your use case. Okay, let's get back to the slides. We've seen that where you understand how those work. If you want to have a general idea of how to write Auditd rules, they're part of the repository. But I have to kind of warn you, if you think the log output of Auditd is arcane, the way you write these rules is almost worse. So just to give you a quick idea of what you would have here. So for example, we could say, and we will probably return to that one, here we have power abuse. Power abuse is basically somebody with sudo privileges looks into the home directory of an unprivileged user. So basically you're abusing your sudo powers to look at other people's data. And the way you would specify that is always on exit. If somebody accesses the home folder from a user with that user ID, accessing something with a user ID that is greater than 1000, so a regular user, then you will log this and we will give it the key power abuse. And this is how we could find this specific rule afterwards. But this, or writing rules this way, probably needs to get some used to. So I personally don't find it super intuitive, but you have the sample rules here and you can probably learn from them. I can show you some of the sample rules that we use ourselves, but let's not get ahead of ourselves. Let's take this step by step. If you want to see some actual rules from community members, there's a nice GitHub repository, Audis Simplify, which actually shows you some rules that made sense for them. So here are the samples of what they have been doing. And here are, for example, the access rules. I mentioned that you could monitor specific files. So for example, here, if somebody writes to any of these, then those would be logged. And then this would be the key, the tag that those events would be tagged with. or you could monitor specific commands. And this is just a reference what might make sense. Obviously, you will need to tweak those for your environment. For example, you could check like somebody bound to an interface, or somebody bound to bound a network connection, and somebody connected to that. Those might be very chatty. Maybe for your specific environment, it still makes sense because you don't have that many network calls, and those should be very well monitored. But in other situations, this might be way too much information, and you don't have the bandwidth to actually collect all of that, to even look through that. So you will need to figure out the right rule set. These are just some examples of things that might make sense to monitor and look at afterwards. Okay. One thing that I think is still work in progress are namespaces, as in container namespaces. So to attribute something, if you have multiple containers running, what is coming from what container is with Auditd still a bit work in progress. And now, once you start collecting all of those pieces of information, showing that on a command line with one host is kind of simple, but probably not very useful, because for your use case, you want to kind of go to the next level and probably monitor more than a single server. So you want to monitor and collect and centralize all the things. And then the question is, how do you centralize all of that information? And that's basically where I come into play. I work for Elastic, the company behind Elasticsearch, Kibana, Beats, Logstash, some other security-related products, for example. And we care about centralizing pieces of information. Maybe you're using us already, or at least have heard of us for a centralized logging solution. And security events are no different. We are happy to collect and centralize those. By the way, sometimes people are confused and say like, well, aren't you a full text search engine? I've heard that you're being used on Wikipedia, Stack Overflow, or GitHub to actually search, which is totally true. But for us, logs, or especially also security events, are totally a search problem. Because nobody cares about collecting all these pieces of information. What you mostly care about is finding what you're looking for. So you probably want to quickly extract like security relevant activities. Or if you know that an account has been hacked, you want to see what has that account been doing. So you want to retrieve the relevant information and not just a lot of data. So it's less about being a data dump than having relevant and fast search to retrieve that. And that's why Elasticsearch in general is a good fit for that. Warning, this is a hello world example of auditing, and yours will be more complicated, but I'm giving you some pointers of where to get started here. If you've never heard of us or seen us, I think most of you will know this slide. So we started with the good old ELK stack. So Elasticsearch is the thing that stores your data, Kibana visualizes, and Logstash is kind of the ETL tool to get, parse, and enrich data. What do I mean when I say parse? So for example, we saw the Auditd log line, and to make the most out of that, you probably want to break out the individual pieces. So if, for example, the type, you want to parse and then say like, give me all the user start events, or give me all the daemon end events. Or you might want to say like, okay, give me everything for a specific process ID, or everything that was successful. So you will want to break this up. This is what I mean when I say parsing. There's also enrichment. For example, I could say like, this is nice, but when I centralize this, I want to know from which host this is coming from, or from which availability zone or node ID on AWS or whatever. That would be enrichment when you add additional metadata that will make your security searches afterwards more powerful. So that would be things that will come into play here. And Logstash is one of the things that can help you out on that. Not the only one, we'll get into more soon. And then we added this other component called Beats, which is like a lightweight agent or shipper, mostly because Logstash is kind of heavy, originally Ruby, now JRuby, so you need the JVM. And Beats are written in Go, so you have native binaries. It's like lightweight shippers. They just forward the data. They don't do this parsing on the spot, but you can centralize that and not do that on this specific nodes. The problem is there is no B in ELK. And then we thought about it, and this is what we came up with. This is the BELK or ELK B, because it has all the names now in it. If we would meet in person, I would hand out stickers of that one. Unfortunately, today I can only show you this picture and not hand out stickers of the Belk or Elk. All of this together, then you can either call Belk, Elk, or we try to call it Elastic Stack because it's more scalable in terms of naming convention. Whatever products we keep adding, and we keep adding more security features and products, for example, Elastic Stack is just one name that keeps evolving and growing with everything that we do. But if you say Elk, we'll still understand. And this is kind of part of the stack that we talk about then. So beats are the agents or shippers that collect everything. For example, they can fetch that Auditd file. They could then forward that to Elasticsearch directly or to Logstash, and you can do the parsing either in Logstash or Elasticsearch. I'll keep it simple today and do the parsing in Elasticsearch actually with the so-called ingest node. And then you store it in Elasticsearch as well, and Kibana can visualize what is going on there. So the obvious thing that you want to have is, I showed Auditd, and probably you want to collect your security events. So we have a so-called FileBeat module to do that. So let me show you some stuff here. So first off, beats are like a family of shippers that do things like we have FileBeat for log files or events, and there's MetricBeat for metrics, and PacketBeat for network data, and Heartbeat to ping stuff. So looking at FileBeat, how did we set up FileBeat to actually collect this log file that I'm showing you above here? So let me quickly open the configuration file here, etc filebeat.yaml. This is where this is living. And what I'm doing here is I'm basically saying I want to use these modules, and I just say Auditd. So if you've used the stack or come from like the older times, then you would explicitly say, this is the file I want to collect. And then you would probably forward that file to Logstash, and then you would write your own parsing rules to parse that. And at some point, we realized that everybody was doing the same thing for the same component. So for example, Nginx is very popular, or just getting the system logs, or this Auditd log. And people were doing the same thing over and over again, like specifying, this is the file I want, these are the parsing rules to do that. And we just package that into the FileBeat now. So all you need to do is you need to say like, okay, I want to collect the Auditd information. And then the beat will know, okay, you're running on Ubuntu 18.04. And this is where the log file is. And this is the default format of the log file. So this is how I will parse and process that. By the way, one word about parsing. Looking at the files that, or the log events that we have here, how much fun do you think it will be to parse those? Probably not so much. First off, how do you parse? Normally writing a regular expression. And then I always ask, like, how much fun is it to write a regular expression? And some people would say, yeah, it's a lot of fun. And most people would say it's not so much fun. Those saying it's a lot of fun, I always say this is like the Stockholm syndrome. At some point, you get so used to writing regular expressions that you start liking it. It's like using YAML for Kubernetes, where it's also the Stockholm syndrome, but most people don't like it. Maybe the only advantage here is that it's like job security. Once you have written a grok rule or a regular expression, it's pretty hard to read, and maybe you can read your own, but reading somebody else's rules is even harder. It's maybe a bit like Perl, like you can write it and maybe read it, but nobody else can read it anymore. So that's not what you want to do. And that's why this module is actually doing that work for you. And with that, we just said like, okay, collect Auditd information. I'm adding some cloud metadata. I'm also adding some host metadata, so it will know like this is an Ubuntu 18.04. And then I'm just storing that in Elasticsearch. So I'm using a cloud cluster here where this is running under the username Philipp. And well, you don't see my password for obvious reasons here, which lives in a key store. And this is all you need. And this will then collect the Auditd events. So heading over to Discover here. So these are all the events that FileBeat has been collecting. So you can see in the last 24 hours, and I only started this demo this morning, we have collected like 16,000 events. But if I open one of these up here, let's see what we have here. I'll scroll a bit further down. And you can see, okay, this is from varlog syslog. So this is actually from the system module and not Auditd. Because, well, I collect Nginx logs, system logs, and Auditd. And now what we want to do is we want to actually filter down on the relevant data set. And looking at all these pieces of information, you can see event dataset, system, syslogs, or event module system. Let's filter down on event module, and we will exclude system and Nginx, or actually we will filter for event module audit. So here, since this is driven by a search engine, we can just search for event module. And then I say, well, this should be equal to, and now it even suggests like these are the three options that you have available here. And I'm just interested in the Auditd logs that I have running here. So let me refresh that. And the slight lag here is the joy of running Zoom in the background to share your screen, which at least on my machine always eats half my CPU, but this is what you get with Zoom. So you can see this was when I was running Auditd, and these are the events that we have collected. So 147. Let me open one of these up here. So what do we have here? So down here, we had add group message, whatever. So this was the message that we have collected. And you can see we have enriched some data here, the host information that was the host metadata. So we know on what operating system this is running, Ubuntu 18.04. We have some pieces of information from the event dataset. So this is from Auditd, and we have extracted that. And you can see here, cloud shows us where this is running. So this is running in EU West 1, so in Ireland, in the availability zone A. This AMI with this instance ID. So this is where this is from. And you can also see we have extracted some Auditd things. So for example, we know from which user this is, the process ID, the operation that we have done here, and it was an add group. So this is what this has been doing. And then I could filter down and say like, do I have more add group events? So I could just click on that plus to filter down on that add group activity here. And after a couple of moments, if my browser manages, we'll see, okay, we had 7 such similar events. So you can see this is the structured filter that has been added to this search as well on top. And this is how you can drill down in your data. And I described before why it makes sense to have a search engine to run through this, because you want to actually use a lot of search features here in the long run. We have also built a dashboard for this. Let me show you a pre-built dashboard. So here we have all the dashboards that we have. And I want to show, I would type correctly, file with Auditd. So we have a lot of different pre-built dashboards, but I want the audit events for now. And this will show us not just the last 15 minutes, because that won't show anything, because that was not when Auditd was running. Let me change that filter to the last 24 hours, and then we will actually find some events. Like there was this little spike when I started the demo in the morning, and that's what I want to show you. So I'll enjoy some coffee while this loads. So you can see these are the users in my system that I have. These are the types of events that we have been creating. This was when we were running our commands. So we had up to 124 events or so per 1 second time frame or so. We have pretty much no failures. And I don't think we have too many geopoints, but maybe we see a bit where some requests are coming from. So the two most prominent geopoints that we see here are, this is me, I'm at home in Vienna. This is our data center, so probably a lot of the requests are coming from within that same data center. But you can see that some requests are also coming from Russia, for example. And we can actually dive into that and then check, like maybe it was SSH brute force attempts, which would not be that uncommon. And then down here, you would have a table with all the individual events. So this is all Auditd. Filebeat can also, I've shown you that it collects the system information as well. So here, for example, I would be curious, like what are the SSH login attempts? And obviously we have a dashboard for that. So I can just look at the SSH login attempts. And then we could see for this single host that has just started like 12 hours ago or so, I could just check like how many people did try to log in. And you can see how many were successful and how many failed. So actually today, not that many, because sometimes you have lots of people from either it's normally China or Russia that try to brute force the instances. So we only have a couple of failed login attempts. And you can see my logins are coming from a public key and not an SSH and not a password. All the failed login attempts were for root. I don't even have a root user on this system, so this will not work out. But you can see, okay, this is where most of the requests have come from. So somewhere in Russia, 5 of these login attempts have come from. By the way, this is a public instance, so you could try to do that as well, and then you would show up here. But I'll give you another chance to actually try something out on that live instance later on. From the log files that we collect from the system, we can also see other things like which sudo commands have people been running, or which groups and users have been created, or just the system logs in general. So for example, with the sudo logs, we'll see that I ran probably a couple of things, like I ran some upgrade commands, and this is what I've just shown you. Like this is the filebeat configuration, and I've run this 3 times with my Ubuntu user here. I mean, there is a root user, but there's no root user for SSH, in case you're wondering. And you can see which users have been using these. And if we had any of these infamous sudo errors where somebody was not actually allowed to sudo, but we don't seem to have those yet. We could generate them and then collect them. But let's continue. So this was the Auditd module. This came a bit for the dog fooding, where we want to get ourselves those auditing events. Though I always prefer to call it drink your own champagne, because it sounds much nicer, and yeah, the French have the nicer style of living than the dog food, I guess. Because we have our cloud service where I'm running this as well. So Kibana and Elasticsearch are running on cloud. And for that, we wanted to get lots of auditing events ourselves. So we wanted to use this filebeat module, and then you saw how complicated it is to parse all of that. And at some point we were like, no, this just feels wrong. We don't want to write complex regular expressions to actually parse that back from Auditd. This is not how this should be. And for that reason, we added another beat, like next to filebeat and metric beat and packet beat and heartbeat, there's Auditbeat. I always forget there's also winlog beat for Windows event logs, but I'm trying to stay away from Windows. Auditbeat is really just wrapping Auditd functionality, but with a little twist or making it better. So it's trying to correlate event IDs. So you will have the process name and the user. So these will automatically be resolved and make the events a bit richer. Also, it ties natively into Elasticsearch, so you don't need to write regular expressions. Rather than writing something out to a file and then parsing it back with a regular expression, you could just create JSON events and store that directly in Elasticsearch. It is written in Go and probably easier to configure. I can show you the configuration afterwards. And part of the reason why we didn't use eBPF, which is also very popular, is that at least 2 or 3 years ago, when we started this, eBPF was not supported by all the kernels, and we had lots of users, sometimes ourselves, on all the kernels. So it's not using eBPF, but it has kind of similar features. Auditd provides those, and that has been around for a long time, so it's supported on old kernel versions as well. And it supports Docker metadata or Kubernetes metadata. So if something is running in a container, you could attribute that correctly to the specific container where this is running. This is all based on a base library. So basically we have written a Go library to wrap Auditd to output or get to those events directly without writing them out to a file. This is open source. Everybody could use that. The main user is Auditbeat though. So let's see what we have here. So if you've paid attention, what will be the configuration file for this one? etc auditbeat YAML. This is the configuration file. And what we have here is we say Auditbeat modules. This uses Auditd. I'm resolving the IDs automatically. I have a backlog limit of how many events I want to store in memory, which takes up 70 megabytes at most. You could rate limit. So for example, if your rules would generate a ton of events and it might be too much for your instance to handle, you could rate limit. I disabled that. I'm not interested in the raw events actually, and I'm not including any warnings. There is a back pressure strategy which I leave on auto. So if you're overloading Elasticsearch on the reading side, back pressure would be to slow down, wait a bit, and then send the remaining events later on. And here with this awesome YAML syntax of audit rules pipe, I can just pass in the audit rules that you would want to have. So these look kind of similar to what you have probably seen before. So for example, I could say here, if I'm logged in with a user in the group 1001, which is my developers group, for example, and somebody accesses etc passwd, then I want to log this with the tag developers passwd read. Or if an admin tries to abuse their power, we could also log that. Down here, there are some of the rules that we are using in production as well. So for example, if anything changes, if a write access happens to these files, we would log those under the key identity, or we have some external access. This can be pretty chatty on accept a network connection, bind, connect, or listen. So these are just some of the samples of the things that we do here. So this is pretty much just like Auditd, just wrapped in Auditbeat. So we can get that into Elasticsearch directly. So let's see what we have here. I head back to Discover, and I will remove this one, and I will remove this one. And then I still need to, if I click on the red field, switch over to Auditbeat to actually get to those. So let's see how many events we had in Auditbeat in the last 24 hours. So probably we will limit that down to a shorter time frame because this will be too many events for what we want, I think. Since I have included the pretty chatty rules like any network connection, my single host created 114,000 events just in the last couple of hours. So I could just say like, I'm just interested in the last hour to get to a bit of a smaller data set here. So in the last hour, we had 20,000 events, and this is what one of those could look like. So let's see what we have here. So you can see here the metric beat running with this call has been running and forwarding some information for us. So this is, let me find the right rule. This is, okay, it opened the socket. So this was part of the network traffic, and this is what MetricBeat was doing. So this was most likely that MetricBeat was actually shipping some metrics off the host. And since I'm monitoring any network connection on that machine, shipping off metrics with MetricBeat is being collected here as well. But you can see, okay, network packets involved, the protocol, that it was IP version 4, you can see which binary, how it was invoked. So all of that is there. So if somebody breaches your system and then tries to send your data out, you could at least figure out like, how did they do that here? Also, you will be able to actually figure out which user was doing that. So here, since MetricBeat is running as root, this was shipped off by the root user. So whatever user account is then being taken over, you see, okay, this is what happens to that specific user account. And I could, for example, now filter down to just what the root user has been doing. And then I could basically walk through all the actions. Like if you log, for example, any call to a binary and every network traffic, you would get a pretty good picture of what that specific user has been up to. So this is just one overview of what you get here. Though this is kind of like the detailed view. Let's get to an overview of what is actually happening in our system here. So let me get back to the dashboards. And I've just checked the time. I'll need to make sure that we continue or get everything done here. So Auditbeat has multiple modules. So for example, let's start off with the overview dashboard. And that will just give you a bit of an idea of what has been running here. You can see this is when we started this. You can see, okay, this were, for example, connected to and bound sockets were the most common events that we have been running here. And then it will fill out my other dashboards and show if my CPU keeps up with Zoom, what else has been running here. And you can see, okay, user logins, Auditd rules, authentications, connected to bound socket. These were the most common events. And you could then dive into those, filter on them. So for example, the bound socket, I could just open that and say, like, I'm only interested for this entire dashboard now in this specific view. And now it would filter down just on that bound socket, those 416 events. And you can see my processes very regularly bind to specific or bind to a socket. And then down here, it will then show you in a moment. This was actually the things that were happening with the bound socket. And this is just one of the dashboards that you could have here. Another dashboard, and this is the last one I will show you, I think. For example, we could head to the dedicated socket dashboard, and that would just have a view just on the network layer, basically. So here you could see in the last 24 hours, how many socket connections we have opened, the destination ports, the source ports, etc. So you can see outbound, inbound, and unknown, the source and destination IP addresses, the ports that have been most used. So you see, okay, I'm serving my HTTPS site, I'm having some DNS traffic, some plain text requests are coming in, some HTTP. You could filter down on any of those. You could filter down on the related users for those. You can see that the histogram on the socket connections is pretty stable, and the individual events. And you could get some information from the host, the logins that you had in your system, which users exist, the processes that are running, which packages are installed. For example, packages are interesting if you have lots of hosts. You could use that packages information to actually see what is installed and if you need to upgrade anything on your system. By the way, some of that information is not from Auditd anymore, but part of Auditbeat only. So to make this a bit simpler, we've added some modules to Auditd to extract some more information. So for example, every minute I'm extracting information about the host, the users, the installed packages, and the logins. And every 2 seconds, I'm looking what processes are running and what sockets are open. So this is one other thing that is like here with a slightly easier syntax to configure that. Auditbeat does run that. But you can see since this is running continuously, like basically at one point in time, it checks the current state. This is not based on Auditd anymore, but this is just a feature of Auditbeat to collect those in pieces of information. And I've shown you that. Those are the so-called system modules, and they can collect these pieces of information. Another thing that you can use is file integrity, which basically looks at a file or a folder, looks which files and folders are there, hashes each one of them, and every time you write to that file, it will then afterwards hash it again and see did the hash change. and then it would store an event and say like, okay, this file just changed. And then you could figure out that something changed on your system. So for example, here I have my website running, and we could change that. And that should be var www html index html. This looks like the right file. And we could just, I don't know, change this. Let's say an attacker comes in and changes your professional website to a less professional website. And we have changed this one here. If I refresh that, you can see now this is here. And we would want to figure out like, when did the attacker change our website, the configuration file, whatever they changed on the file system. And that is part of the file integrity module. So here you could then say, where did we have it? So here we have the event category. I think that should be the right one. Event category. And you can just use this in the structured format and see where this came from. Probably this is not happening often enough, so we need to search for it. I hope this is the right one. Event category equals and this is not the one I want. Maybe it's in the event module, but I'll make this simpler on myself. I will just show you in the dashboard. So we have, obviously we have a file integrity dashboard as well. And there you can just see which files have been changed to monitor. By the way, the configuration file for this one is this one here. So I said anything in var www html should be monitored. I'm not monitoring the VI files or any Git files. You can say like how many files or how much data you want to scan per second, and if you want to have a maximum size of files you want to scan, because otherwise the hashing might get expensive. And I'm using SHA-1 because it's pretty well implemented in modern CPUs. So this would just check those. And you can see here, VI is always doing this move way of changing files, and this is what we have found here. And you can see, okay, this is what has changed. And we could then see, okay, the actual change event. So here, this was when the scan found it initially, and then we have changed 4 events now on this host, and we could then look into this specific event here of what actually happened. So this shows you all the information, like, okay, the event action here was initial scan, and the event module, this is the one I should have filtered on, is called file integrity to find all those changes. And you can see here, this right now was when we moved or changed that file. Okay, we have like 5 minutes left. Let's wrap this up. So here, these are all the algorithms you could use to hash your files. SHA-1 is the default. The most efficient one is this one, by the way. Anyway, if you want to run this on Kubernetes, run Auditbeat as a daemon set, so it runs once on the Kubernetes host. If you want to see that configuration, it's part of the Beat repository, and you have the config map and the daemon set setting there, and those should be the right starting points to run this on Kubernetes as well. You can add Docker and the Kubernetes metadata to tie into that. There's also the audit log from Kubernetes itself, which is kind of an audit log, similar but not exactly the same, which you could get like this. So this is the audit event log against Kubernetes, And this would then generate a log file, and you know how to handle log files with our stack. So you could just handle this in a similar fashion. And this way you can get a very good overview of what's happening in your Kubernetes cluster as well, for example. My colleague James just did a session on SIEM before. And I don't want to go too deep into that. Something that you have seen sometimes, ECS is an abbreviation, which stands for Elastic Common Schema, which is like the naming convention that we use. And based on that naming convention, we can build all of those dashboards. And if you stick to those naming conventions, you can tie into that and also correlate data very easily. And what it does basically is it's a naming convention that says like the field thread.framework is this data type and has this meaning. And this is, for example, of what it should be called. And the thread tactic ID is, according to this standard here in attack, how you would follow this naming convention. And this has a format for logs and any kind of other event type that you might run into. And then you could see that in our SIEM, where you could, for example, see, okay, flow is the network data and the sockets open and the DNS requests and the TLS requests and Nginx access logs. All of those could then be visualized with SIEM, and you could just, with drag and drop, very easily figure out what is going on here. And we also provide rules. So I could, for example, show you an example now. If I open an outgoing SSH connection from my host, which might be uncommon because oftentimes your Linux servers shouldn't SSH to other servers, you could automatically get an alert to investigate that something has happened here that you might not expect. And this is one of the 100 something rules that we ship with SIEM, which can automatically run in the background and alert you when something unexpected on your system happens. I'll skip the demo for the time. Final point, scaling this, because scaling is the important part here. We have these life cycles that you can run through with your data. So when your data comes in, it's hot, and then at some point it gets warm, and at some point maybe it's cold, and then you delete it. And to do that, we have something called index lifecycle management, which basically moves your data from one phase to the next, which in code, this is where this is implemented. These are basically the actions that you could do. So for example, you could say on some nodes, we have the current data, and then on some slower nodes, you have the older data where you accept that your queries will be a bit slower. And also you don't write to those anymore because that's read-only data. And at some point you might delete the data because after 180 days or so, you're not interested in the security events anymore, or after 90 days, or whatever your intention is. And you could configure all of that with this ILM. It also has a UI in Kibana, so you could just click that together. Final note, there's also machine learning, which is anomaly detection a bit more, for example, which you could run on events. And this was just an Nginx server that I was running, and you could see like, this is the number of events. And at some point when you have a spike, it could automatically tell you, okay, there was something unexpected that didn't fit the rest of the data, and you could then start your actions on that. And with that, I think we're pretty much out of time. Just to wrap up, I always compare this a bit to a box of Legos. So you have a lot of different tools that you could use, like the different beats, and then the features that Auditd offers, and the modules that Auditbeat has. All of those combined can build a very strong security foundation to collect what is happening on your event, on your systems. And then you can slice and dice that in Kibana, either with SIEM or with the classic dashboards Discover. These were the pieces that we covered basically. Auditd, if you want to write regular expressions, but wrapping it in Auditbeat makes this a lot simpler. And then you can scale it, run it in Kubernetes, work with SIEM. So this is then the scaling and making it work well for larger environments part. If you want to try all of that out, all the sample configs and everything is on GitHub. So Auditbeat in action is where you can get that code. I will share the link to the slides afterwards. If you want to look at similar solutions, Slack, they have wrapped Auditd in a Go thing that spits out JSON as well. There's also this other thing here, or shape, that can spit out JSON or XML if you really want to have XML. I don't think so, but maybe. And with that, that's pretty much it. This is where you can get the slides. I think we're pretty much right at the end of this session. So let me head back to Vimix and see how we're doing.
Hi, Philipp. Thank you very much for the talk.
My
We
pleasure.
have, it looks like, only 1 minute or so for a question. Let me check if we have something in the chat. Guys, please, if you have questions to Philipp, just write it right now. And I would like to remember that you can join also the Zoom conference with a link on
I
the
will
bottom
join the Zoom afterwards.
to ask all your questions personally. Okay, it looks like there is no question so far, Philipp, so maybe some people will ask in a Zoom. Thank you once again.
Thanks a lot. Thank you. Bye.
Bye.